Alright, today we're going to talk about something called Radian Measure. But before we get there, we have our standard circle here, and up until now, the way we measure an angle, whether it's in a circle or outside of a circle, is with degree measurements. And if we take a circle and measure all the way around it, we know that that is 360 degrees. But we don't really know why a circle is divided up into 360 parts. Some mathematicians have tried to trace it back, the history of this, and we think perhaps the ancient Babylonians decided that, well, 360 is good because it is a decent size measurement, or it divides it up into enough little bitty parts to take accurate measurements. And 360 is also divisible by several numbers, by 10, by 2, by 6, by 120, by 12, all sorts of numbers. So we seem to think that we take a circle and divide it up into 360 degrees because it seemed to be a convenient number. The problem is it's rather arbitrary. We could have divided this circle, up into 100 pieces all the way around. We could have divided it up into just 6 or so, or 8. So again, it was really rather arbitrary to choose 360 little slices to divide up a circle. So what we're going to do today is come up with a different way of measuring that angle. And we're not going to use degrees, although we're going to relate it back to degrees. And what we're going to start with is something called the unit circle. And the unit circle has a radius of 1. When you have a radius of 1, think about the circumference of a circle, the distance all the way around. The distance all the way around the outside, we know the formula is 2 times pi times the radius of the circle. When the radius is 1, then the distance all the way around a circle ends up being 2 pi. We can relate that back to our angle measurement of 360 degrees, because 360 degrees is going to be equivalent when I travel all the way, when I sweep a circle of 360 degrees, my arc length in the unit circle is going to be 2 pi. So we're going to define this new angle measure called radian measure. And we're going to define it using the unit circle. So I want to define that angle not in degrees, but some other way, starting with the radius of 1. Okay, that's our unit circle. We have a radius of 1. So here's how I'm going to define this new angle measurement. I'm going to say that this angle, the measure of this angle in radians, the measure of that angle in radians is going to be equal to the length that is swept out by that angle in the unit circle, the arc length. So, the radian measure of an angle is equal to the arc length subtended by that angle. We know what subtended means. It means the arc that's created by the two endpoints of the angle, subtended by the central angle in the unit circle. The radian measure of an angle is equal to the arc length subtended by the central angle in the unit circle. So let's look at some examples of this. What we need to do is relate this back to the circumference eventually. So if I have an arc length of 1 radian in my unit circle, so I have a radius of 1, and my arc length has a measurement of 1 unit in the unit circle, then that angle measurement is 1 radian. Theta is equal to 1 radian, and radians don't have any units to them. If I have an arc length of 2 units, so the arc length has units, the radius has units, the actual angle measurement in radians does not have units. If this arc length is 2 and the radius is still 1, my angle measurement is 2 radians. Now we're going to relate the radian measure to something we already know, which is the circumference. We know the formula for circumference is 2 pi r. We're going to stick with the unit circle, and here's what we're going to do. I have a radius of 1, and if I think about going all the way around the circle, so if I can relate a degree measure all the way around the circle, that is 360 degrees. If I relate that to the actual distance around this circle, I know in the unit circle that's going to be 2 pi because the radius is 1. So 360 degrees is equivalent to 2 pi radians. I'm going to spell it out just once, but we usually don't spell it out for radians. If I think about going around halfway around the circle, I know that halfway around the circle is 180 radian, or 180 degrees. So if I look at this is 180 degrees. I want to relate that to half the circumference. So if the full circumference is 2 pi, half the circumference is just going to be pi radians. So now we know that there are pi radians in 180 degrees. This is the proportion we can use to solve for radians, or to convert degrees to radians. I know that halfway around the circle, just think about it, halfway around the unit circle, we know it's 180 degrees. We know the circumference in the unit circle halfway around would be pi. That's where this proportion comes from. So if I want to convert, let's say 90 degrees to this radian measure, it's just a different way of measuring the angle. Here's what I can do. X over 90 is equal to pi over 180. And you set up the proportion and cross multiply. When you cross multiply, you end up with x is equal to 90 pi over 180, and in terms of pi, that ends up being pi over 2. That's usually how we write it, or you could say 1/2 pi. Let's convert one more. Let's look at 60 degrees. If I want to convert that to radians, I know that there are x over 60 is going to be the same proportion as pi over 180. So when I cross multiply, I can say that x is going to be 60 pi over 180, and that reduces down. 60 divides evenly into 180, and we get the radian measure for 60 degrees is pi over 3. If you wanted to convert back from radians to degrees, it's pretty easy to do because, again, you know there are 180 degrees in pi radians. So if you start with, let's say, pi over 2 radians, and you want to convert to degrees, you replace the pi with 180 and simplify. So this is 180 over 2, which takes you back to 90 degrees. So that's the basic process for converting from degrees to radians and radians to degree with this new measurement called Radian measure.